Despite the recent heat, it's not a tropical place. Most farmers in our region know there are just some things you shouldn't try to grow.
What happens when farmland pushed to the brink by chemicals suddenly gets an unexpected visitor? In parts of China, rice fields saturated with pesticides were facing a quiet collapse. Crops were weakening, soil life was fading, and farmers were running out of solutions. Then something unusual happened. Thousands of ducks were released directly into those same fields. No machines, no new chemicals, just birds moving through the water.
Yeah, who can't love a duck? I mean, they're fun. They're fun.
At first it looked chaotic, but what started happening beneath the muddy surface left farmers, scientists, and observers asking the same question: how could something so simple change everything? Devastation of chemical rice fields. Across vast stretches of farmland in China, rice fields once vibrant with life have been pushed to their limits. Decades of heavy pesticide use, up to 4 million tons every year, have taken a severe toll on these ecosystems. What should be thriving fields of young rice plants now bear the scars of chemical dependency, weakened soil, shrinking biodiversity, and fragile crops that struggle to mature. Beneath the surface, the very foundation that sustains rice growth, the soil microbiome, has been disrupted, leaving farmers caught in a growing trap. This damage doesn't just affect individual plots of land. Rice fields are interconnected parts of a complex system that feeds billions globally. When these patches of earth lose resilience, the ripple effects endanger food security on a massive scale. The problem is urgent, yet invisible to most. Fields that once produced ample harvests are showing signs of collapse. Crop failures are increasing, and yields become impossible to sustain without ever greater chemical inputs. Such reliance on pesticides has created a vicious cycle. As soil health declines, farmers respond by applying more chemicals to maintain yield. This only deepens the degradation, causing further losses in soil fertility and microbial life. The ecosystem that once naturally controlled pests and nurtured crops is fading away, replaced by a fragile, artificial balance. Despite the vast amounts of chemicals poured into fields every season, pest outbreaks and weed growth remain persistent problems, costing farmers dearly. Many farmers are left feeling powerless, watching their fields become less productive year after year. The soil's ability to regenerate diminishes, and patches of farmland that provided reliable food are slipping into crisis. This slow collapse threatens the livelihood of millions and places immense pressure on the global rice supply. What makes this situation perplexing is that solutions are typically sought in newer chemicals or advanced technology, but none have fully reversed the damage. The present situation raises a question about the possibility of maintaining industrial farming operations. The evidence shows that increasing chemical and mechanical usage does not resolve the primary issue. Humans are losing something that exists as a biological element that remains hidden from view. Researchers use modern farming methods to investigate the causes of dying rice plants and polluted water bodies. Surprisingly, within this bleak environment, a method once thought outdated is being revisited with fresh eyes. The simple design and ecological principles of this solution. The specific problem remains unsolved, yet it presents an interesting possibility which suggests that natural systems need restoration instead of additional technological solutions. The rice fields will achieve their future results through the revival of ancient agricultural techniques, which have protected land resources for numerous agricultural societies throughout history. The traditional system will not survive the time period when chemical exposure lasts for several decades. The hidden nature of this mystery initiates a process that results in a major change that discredits current established opinions. Farmers who experience both despair and hope can now understand how their land will recover if they provide it with sufficient time. The present agricultural crisis originated from agricultural practices that developed during previous periods of time. The upcoming section demonstrates why adopting an earlier technique will provide the world with its most important revolutionary advancement. This fragile moment between ruin and recovery is critical, and the shift in thinking it demands will test long-held assumptions. The surprising answer waiting beneath the water's surface in these battered fields will change how farming is understood forever. The hidden cost of industrial farming. Over the past century, agricultural landscapes worldwide have transformed dramatically. Farms grew larger and more mechanized as tractors, harvesters, and sprayers replaced manual labor. Synthetic fertilizers sped up crop growth, and pesticides promised unprecedented control over pests and diseases. The result was staggering. Global food production soared, enabling a rapidly growing population to be fed on an unprecedented scale. Yet, these gains came with hidden costs few understood at first. The relentless push for higher yields has disrupted nature's cycles. Chemical fertilizers, while boosting plants, have altered soil chemistry and the microbial communities vital for maintaining fertility. Pesticides, designed to eliminate pests, have inadvertently harmed beneficial insects and soil organisms, unraveling the delicate food webs below ground. This shift towards industrial agriculture has also made farmland a major contributor to global greenhouse gas emissions, responsible for up to a quarter of the world's total each year. Most of this comes from chemical inputs and the degradation of soil, which used to act as a carbon sink. Instead, year after year, these fields release methane and nitrous oxide, potent gases, accelerating climate change. The loss of biodiversity is another alarming consequence. Species that once thrived in and around rice fields, frogs, dragonflies, and small fish, have largely disappeared, leaving ecosystems impoverished and less resilient. This decline awakens a worrying scenario where biological defenses vanish, compelling farmers to depend ever more heavily on chemicals in a dangerous downward spiral. The agricultural land across the world faces decreased ability to restore itself despite the increased funding for agrochemical products, which research shows costs farmers additional chemical dependency for their crop yields to remain stable. Scientific studies show that more than 40% of the world's farmland suffers from degradation, which forces farmers to increase their fertilizer and pesticide application rates in order to achieve equivalent or slightly higher crop yields. The global food supply depends on rice fields that serve as the main source of this crisis. The flooded ecosystem of this region becomes extremely susceptible to damage from chemical waste and the destruction of its natural environment. The absence of a proper organism balance within soil and water environments leads to uncontrolled pest and disease outbreaks, which disrupt fundamental nutrient recycling functions. The industrial farming model, which emphasizes control and standardization, has reached its operational boundaries. The system manages land resources as mechanical assets, which require operational oversight, whereas it should treat land as a biological entity needing protection. The mechanistic perspective of ecosystems creates an oversimplified view that fails to recognize the essential biological links that sustain ecological systems throughout their entire time span. Modern farming methods develop the same difficulties that they originally aimed to resolve. The need for alternative solutions becomes more critical as these problems emerge. Will agricultural production be able to keep growing without damaging farmland and intensifying climate change effects? The solution requires combining contemporary scientific knowledge with ancient cultural practices, which involve studying the agricultural techniques of rice cultivation. East Asian farmers had their chemical-free farming operations, which enabled them to handle agricultural risks by utilizing natural environmental cycles. This path may hold lessons that speak directly to the failures of industrial agriculture and the promise of regeneration. Ancient duck rice farming revived. Long before the advent of synthetic chemicals, rice farmers in East Asia developed a unique system that blurred the line between cultivation and the natural ecosystem. For centuries, rice paddies were home not only to plants, but also to flocks of ducks released into the flooded fields shortly after transplanting. These ducks moved freely throughout the shallow waters, eating insects, weeds, and disturbing the soil surface in ways that supported the rice plants. This traditional duck rice model was not a marginal curiosity. It was a mainstream practice for over 600 years. Farmers recognized the symbiotic relationship between ducks and rice, observing how the birds helped control pests and fertilize the soil with their droppings. Importantly, this system required no chemical pesticides or mechanized equipment, relying instead on biological balance maintained by the interaction of species. The ducks acted as natural pest managers, targeting insects like brown planthoppers and stem borers that are notorious for damaging rice crops. Their constant movement interrupted the life cycles of these pests at early stages, reducing the need for any human intervention with poisons. This resulted in healthier plants and less crop loss. At the same time, ducks fed on young weeds that compete fiercely with rice for nutrients and sunlight. By nibbling on these plants and disturbing their roots, ducks prevented weeds from forming dense mats that would choke the crop. This natural weeding process sustained fields with minimal effort. The gentle stirring of the water by the ducks' feet introduced oxygen into the mud, improving soil conditions that chemical farming often damaged through compaction and chemical toxicity. This natural tilling encouraged rice roots to grow deeper and stronger, increasing resilience to stresses such as drought or disease. Ducks' droppings enriched the soil with nitrogen and organic matter, releasing nutrients steadily and reducing pollution risks commonly associated with chemical fertilizers. The integration of this system meant fewer external inputs and more sustainable cycles of fertility within the field. Despite appearing chaotic, the method required precise timing and management. Ducks were introduced only once the rice had established enough strength to tolerate their presence. Farmers had to monitor duck density carefully to avoid overgrazing or damage to the crop. These details, passed down through generations, were key to the system's success. This ancient method is now seeing renewed interest as farmers and scientists recognize how it naturally balances pests, weeds, and soil health. It challenges assumptions that modern agriculture must always rely on chemicals and machinery to feed billions, suggesting that sustainability might come from partnerships with nature instead of domination over it. With these seeds of traditional wisdom revived, the next question is what exactly happens in these fields when ducks take up residence, and why does it work so well even after modern chemical assault? As wild as the field seems with ducks gliding and digging, a quiet restoration unfolds beneath the rippling surface, rewriting the story of agriculture from the ground up. How ducks restore ecosystems. When thousands of ducks take to the rice paddies, the scene might at first seem chaotic. Flocks wandering without fences or handlers, their footsteps stirring murky water while rice plants sway uncertainly. Yet beneath this apparent disorder, a highly effective natural system quietly unfolds. The ducks are not harming the fragile crops. Instead, their activity transforms the ecosystem in ways modern agriculture struggles to replicate. The duck's primary role is biological pest control. They feed on a variety of insects that threaten young rice plants, including brown planthoppers, stem borers, and leafhoppers. These pests can devastate rice yields if left unchecked. But the ducks interrupt their life cycles early on, keeping populations low without any chemical intervention. In just a few weeks of duck activity, farmers notice a significant drop in these harmful insects. Beyond insect control, ducks are relentless consumers of weeds, competing plants that rob rice of vital nutrients and space. Young shoots of duckweed, barnyard grass, and even wild rice are devoured, preventing them from forming thick mats that smother crops. Every step the ducks take physically disrupts weed roots, impairing their growth and giving the rice a competitive advantage. The ducks' movement also aerates the water and soil. As they paddle and probe, they introduce oxygen into the otherwise stagnant, anoxic mud, conditions that chemical farming often worsens. This gentle disturbance reduces soil compaction and promotes deeper, stronger root development in rice plants. Scientists liken it to a form of natural tilling that happens continuously throughout the day, without heavy machinery. The fields receive continuous organic nitrogen and organic material through the natural distribution of duck droppings. The soil receives a continuous nutrient supply from this system, which enables plants to grow while supporting microbial life, instead of creating a single massive fertilizer application that synthetic fertilizers use. The system decreases chemical runoff and pollution, which usually happens in chemical-heavy methods, while it safeguards nearby waterways. The ducks serve as a natural defense against harmful aquatic species. Their constant water surface disturbances lead to mosquito larvae destruction while disrupting the development of multiple parasites that depend on unchanging aquatic environments. The ecosystem gains from this development because it decreases the requirement for chemical pesticides while creating a healthier environment with greater biodiversity. All these benefits depend on a delicate balance. Ducks prefer to hunt moving things or fast-growing plants, which farmers want to keep away from their fields instead of attacking rice plants. The rice stalks mostly avoid being trampled because the birds naturally steer clear of healthy plants, allowing crops to flourish amidst their caretakers. The rice duck system has proven itself through history to sustain stable yields while protecting soil health and avoiding chemical dependency. The soil maintains its fertility throughout the seasons, while pest outbreaks appear only on rare occasions. The relationship functions as a dynamic alliance that uses natural animal behavior to sustain equilibrium without relying on artificial substances for control purposes. This natural balance shows how farming differs from chemical-based mechanized agriculture. It presents an agricultural model where plants and animals engage in joint work within an ecosystem that has been harmed by industrial practices. But to work effectively today, this ancient practice needs careful management and timing. Balancing ducks and rice for success. Introducing ducks into rice paddies is not as simple as opening the gates and letting them loose. The positive effects that sustain the rice ecosystem hinge on precise timing and careful management. Ducks are introduced only 2 to 3 weeks after transplanting, when rice seedlings are robust enough to withstand disturbance. If released too early, young plants risk damage. Too late, the biological benefits in pest and weed control are reduced. Duck density must also be carefully controlled. Studies conducted in China and Japan suggest an optimal range between 150 and 300 ducks per hectare, depending on factors like soil type, water depth, and rice variety. Too few ducks will have a negligible biological impact, failing to replace chemical inputs, while too many can cloud the water and stress plant roots, impairing photosynthesis and affecting yields. The duck's presence inside the paddies needs to be closely monitored throughout the growing season. Their continued movement stirs the water, disrupts pest life cycles, and controls weeds, but excessive density or prolonged presence can backfire, stressing the rice plants and reducing productivity. This delicate control requires skill, knowledge, and constant observation by the farmer. Another critical phase is the timely removal of ducks. When the rice enters panicle initiation, the stage when the plant prepares to produce grain, ducks must be completely withdrawn. This is the most sensitive period for rice, as even minor disturbances can significantly affect grain number and quality. Properly timing the duck's exit safeguards the crop's reproductive success. The balance achieved in these systems is a lesson in working with nature, not against it. Farmers must blend traditional knowledge with current environmental conditions, adapting practices carefully. This contrasts sharply with industrial agriculture's one-size-fits-all approach and reveals how nuanced biological relationships require attentive management. Rice duck farming also demands more hands-on labor and supervision than conventional mechanized methods. Farmers need detailed knowledge about water levels, plant development stages, and duck behavior to ensure harmony between species. This human ecosystem interaction becomes a skill passed through generations, but it can be a barrier when labor resources are limited. Despite these challenges, the returns are substantial. The system reduces reliance on costly pesticides and chemical fertilizers, trimming input costs significantly from the very first season. This benefit supports small-scale farmers confronting rising input prices and market uncertainties, enhancing both economic and ecological resilience. This careful calibration of ducks and rice exemplifies how ancient practices can adapt to modern challenges. It highlights that with the right balance, nature's complexity can become agriculture's greatest ally rather than its adversary. But mastering this balance is key. It unlocks a sustainable future that modern methods have sought but not yet found. The water glistens in the fields where ducks have danced all season. But beneath its surface, another story of precision, patience, and partnership quietly unfolds, revealing how nature's rhythms can guide farming back to health. Economic and environmental benefits. Introducing ducks into rice fields creates benefits that ripple far beyond pest control and soil health, reshaping both ecological and economic landscapes. One of the most immediate advantages farmers see is a dramatic reduction in the cost of chemical inputs. Studies in China and Japan reveal pesticide use dropping by 50 to 70%, while the need for synthetic fertilizers falls by 20 to 40% per hectare. These savings often take effect in the very first growing season, easing financial pressure on farmers facing rising input prices. Lower production costs translate into improved economic resilience, especially for small-scale farmers whose margins are tight. But the benefits don't stop there. Rice grown in these duck-integrated systems often falls under classifications like ecological or low-chemical rice. appealing to consumers who prioritize food safety and sustainable farming. In many Asian markets, such rice commands prices 10 to 30% higher than conventionally produced varieties, creating a powerful incentive to maintain these practices. The ducks themselves become valuable economic players in this cycle. Fed by natural food sources within the paddies, they grow quickly with little need for commercial feed or antibiotics. At the end of the season, farmers can sell duck meat or eggs, diversifying their income and reducing dependence on fluctuating rice market prices. This additional revenue stream can offset a significant portion of rice production costs, turning the system into a balanced economic model. The environmental recovery process in fields occurs through natural processes, which return them to their original state. The fields experience a transformation that results in clearer water and decreased algal growth after they lose their chemical-based pollution and stagnant conditions. The odor of anaerobic decomposition disappears as it gives way to pure water from living organisms. The return of beneficial insects is followed by frogs, small fish, dragonflies, and various water birds, which bring back the lost biodiversity to the area. The process of life restoration in this area brings back the natural biological mechanisms that had previously maintained balance for pest and disease control. The ecosystem gains stronger protection against collapses while it maintains its ability to produce resources throughout numerous growing seasons. The rice field stops functioning like a factory pushing for maximum starch output and instead becomes a balanced habitat supporting interconnected species. The climate advantages of this situation reach substantial levels. The research demonstrates that rice fields that use duck management practices result in 20 to 30% decreased methane emissions when compared to traditional chemical-intensive rice paddy systems. Rice fields that experience stagnant flooded conditions create anaerobic soil environments, which lead to methane production. The ducks create continuous movement, which results in soil aeration that decreases anaerobic conditions while achieving significant greenhouse gas emission reductions. The practice of duck rice farming goes beyond its capacity to decrease environmental damage because it serves as a direct method to fight climate change. The system demonstrates a transition to regenerative agriculture because it restores soil health while re-establishing nutrient cycles and maintaining ecosystems throughout multiple years without depending on chemical solutions. The future will display a system where agricultural production works in harmony with environmental protection. The combination of all these advantages creates an attractive farming method that achieves three goals: reduced input expenses, increased production of high-value crops, enhanced ecological diversity, and a battle against climate change. Yet, achieving this balance is complex and demands careful attention to detail, as ecological systems rarely thrive under carelessness. Challenges and limitations. While the rice duck system offers many advantages, it is not without its challenges and limitations. Managing a living ecosystem is far more complex than simply applying fertilizer or spraying pesticides on a schedule. It demands knowledge, precision, and constant vigilance from farmers. The timing of duck release, the moment they are removed, the density of birds in each field, and the management of water levels all play critical roles. Rice growth must also be closely monitored throughout the season. A small miscalculation, such as introducing ducks too early or allowing too many birds into one area, can quickly shift the system from helpful to harmful. Instead of supporting the crop, the ducks could damage seedlings or disturb the soil too aggressively, placing both yield and income at risk. Predators also present a serious challenge. Ducks moving freely through open rice paddies can attract a variety of animals looking for an easy meal. Snakes, foxes, feral dogs, and birds of prey are among the most common threats. Without proper protection, a farmer could lose a large portion of the flock in a short period of time. Preventing these losses often requires fencing, night shelters, and increased monitoring. All of this adds labor and infrastructure costs that many farmers must carefully consider before adopting the system. Environmental conditions can further limit where duck rice farming works best. Not every rice-growing region can support this integrated method. Fields that lack a stable and reliable water supply may struggle to maintain the shallow flooding required for ducks to move and forage effectively. Likewise, steep or uneven terrain can make it difficult to manage both the birds and the crop. In some areas, years of chemical contamination have left the soil and water so degraded that restoring ecological balance becomes extremely difficult. In such cases, biological recovery may take many seasons before the system can function properly. The labor demands for agricultural work have increased beyond the requirements of traditional tractor farming methods. Farmers who use chemical pesticides and fertilizers can operate their farms from a distance after they apply their agricultural inputs. The duck rice farming system needs continuous crop monitoring and farmer active involvement to succeed. Farmers need to observe how ducks behave while they track plant growth and decide when to change water levels and bird activities. The required level of concentration becomes difficult for people who live in areas with decreasing rural populations and for farmers who already handle several work obligations. The system faces additional challenges when it needs to be implemented at industrial farming operations that cover extensive areas. The operational framework of contemporary industrial agriculture requires farmers to implement standardized techniques and use equipment that functions efficiently throughout their entire farming areas. The successful implementation of duck integration requires farmers to customize their techniques according to their specific circumstances. Different climate conditions, soil types, and types of rice plants require each field to have its own unique stocking density, operational timetable, and management methods. Another barrier exists because of people's existing beliefs and traditional practices. Farmers who work in the present day have depended on chemical fertilizers, pesticides, and machinery for their entire professional lives. The process of changing to an ecologically balanced system demands both time and the ability to test new methods. The process needs both educational resources and scientists' trust in unfamiliar approaches that exist outside of modern agricultural conventions. The pilot programs and community-based projects prove that the existing difficulties can be solved through their implementation. Farmers who use traditional knowledge together with scientific advancements can develop better methods that safeguard duck populations while ensuring healthy crops and ecological advantages. The restrictions of duck rice farming demonstrate that no agricultural method provides a solution that works in all farming environments. Where nature's lessons meet real-world constraints, the path toward healthier farmland demands both humility and innovation, inviting us to rethink how productivity and sustainability can coexist in harmony. Nature's wisdom for modern farming. As industrial agriculture confronts mounting challenges, ancient practices like rice duck farming are revealing powerful lessons for the future. These traditional methods emphasize harmony with nature rather than control, offering a model where ecosystems sustain themselves rather than relying on chemical rescue. Modern farming stands to benefit by rediscovering how to work with biological cycles instead of overriding them. The rice duck system embodies principles of regenerative agriculture, which seek to restore soil health, rebuild biodiversity, and reconnect nutrient flows. Unlike industrial models that treat soil as inert ground to be pushed to extremes, this approach recognizes the living soil community as central to sustained productivity. Ducks, plants, insects, microbes all interact in a balanced loop that keeps pests low and fertility high. Reviving such ecological knowledge requires more than just adapting old techniques. It demands integrating scientific understanding with local experience and careful observation. Precision in timing, stocking density, and water management is vital. This combination of tradition and innovation creates farming systems capable of withstanding growing pressures from climate change and resource scarcity. Importantly, this wisdom calls for viewing agriculture as part of a broader landscape and community. Rice fields linked to natural waterways, wetlands, and biodiversity hotspots function best when managed as living systems. Pushing for maximum yield without regard for these connections risks further degradation and locked-in dependence on chemicals. The rice duck model demonstrates that economic success and environmental protection can work together. Ecological rice produces higher market prices, while on-farm duck production creates multiple revenue sources. The system demonstrates that organizations can achieve sustainable practices with profitable outcomes through their use of nature's fundamental principles. The establishment of ecological balance needs all agricultural stakeholders to adopt new value systems and mental frameworks. The statement challenges the belief that agricultural problems can be resolved through technological solutions. The approach requires people to recognize complicated issues and wait for nature to unfold, while understanding that their capacity to manage situations is restricted. The rice duck system provides a framework that different areas and agricultural systems can utilize, although it does not work as a universal solution. The system supports testing that combines local practices with traditional customs for farmers and scientists to create sustainable solutions. The system provides a different approach by using flexible methods, while industrial standard solutions create uniformity in products, which develops sustainable food systems. The increasing worldwide population combined with rising environmental pressures creates an urgent need for restoring agricultural ecosystems. The use of traditional natural partnerships, which include rice and ducks, will help develop regenerative farming systems that provide food for everyone while restoring ecological balance. The insights from ancient times continue to hold great value, which needs urgent application in contemporary society. The rice and duck story shows that development does not need to become more complicated. People can achieve the greatest environmental protection through their most elementary natural solutions, which provide reliable methods to sustain the essential resource of soil. From poisoned fields to thriving ecosystems, ducks have offered a surprising remedy for modern agriculture's toughest problems. This story reminds us that reconnecting with nature's rhythms can unlock sustainable food security. If you found this journey inspiring, please like the video and subscribe for more stories about the hidden systems shaping our world. And before you go, take a moment to watch the next video now appearing on your screen. It reveals another surprising system quietly changing the way our world works.